All right, boys and girls, welcome back to the drive-through for your second 3-2 lecture in Algebra 2, brought to you by the deli. Hungry? Stop by the deli and get yourself some of Mr. Tilton's famous three-ways, please. Okay, so we've already done solving systems of equations by graphing. We've done solving systems of equations by substitution. And now we're going to learn the final method, and that's the elimination method, okay? And it's exactly what it sounds like. The elimination method, if you want to, yesterday I gave you like a little description of the substitution method, so I'll give that to you today. The elimination method uses strategic algebraic operations. Let's try to make this as dorky as we possibly can. Can I use eliminate? To remove one of the variables from a system of equations. Oh, well, okay. Here's what's going to go on. If you've got two equations, then those things are true, because that's the power of the equal sign, as we learned yesterday. They were given to you. But once again, our problem is we have two variables, and we have two equations. We want one variable and one equation. Well, since these things are true, we can add them together and that result will be true. We could subtract them and that result would be true. So what we're going to do is we're going to take, I'm just going to rewrite these real quick. 4x plus 2y equals 9, and negative 4x plus 3y equals 16. We're just going to add those bad boys up in this case. We don't always add them, but we are in this one, because what's 4x plus negative 4x? 0. Sweet. 2y plus 3y is 5y. That would be a plus in there. And then a 9 plus 16 is 25. So we know that we divide each side by 5, and we get y is 5, okay? Well, now, to find our x, you've got to use the substitution method again at the end. You're going to plug y in. I plugged it in for that one because I prefer to avoid negatives, but if you wanted to, you could plug it in for that one too. They both will give you the same value for x. They have to, or it wouldn't be a solution. So, 4 times x plus 2 times 5 equals 9. I took out the y and I put in the 5 because y is 5. Powerful. So you get 4x plus 10 equals 9. Subtract 10 from both sides. You get 4x equals negative 1. X is not 4. X is negative 1/4, okay? Or negative 0.25. So our solution to this equation would be, I'll write it over here, negative 0.25, 5. Okay? So now you know your third method. Elimination, substitution, graphing. Okay? Sometimes the directions will tell you which ones to use, and sometimes they will not. For example, this one just says, what's the solution of the system of equations? You could do this any way you want, but I want you to notice that none of these variables are easy to solve for. Okay? So the substitution method wouldn't be the best one to use here. So this is going to be the hardest version of a system of equations that you do for this section. All right, you got 2x plus 7y equals 4. And you've got 3x plus 5y equals negative 5. Well, we can't just add these up and get rid of them. We can't subtract them and get rid of them. So what we're going to have to do is change them. And we're still allowed to change these things if we multiply both things. So what I'm going to do is multiply this whole thing by 3. So what I've decided is I'm going to try to eliminate the x's. So follow what I'm doing here, okay? I'll try to explain it and go kind of slow. When I multiply that whole thing by 3, I get 6x plus 21y equals 12, okay? Well, if I take this one, whoops, and multiply it, what would I want to multiply this one by so that it would be easy for me to use the elimination method? Well, I'd like for x to be negative 6x, right? That's what I would like for that to become. What would I have to multiply this by for my 3x to become negative 6x? I'd have to multiply it by negative 2. So negative 2 times 3x is indeed 6x. Negative 2 times positive 5 is a negative 10y. And negative 2 times negative 5 is a positive 10. Okay? Wow, there it is. Now I can use the elimination method. If I simply add up these two equations, 6x plus negative 6x is 0. 21 minus 10y is 11y. 11y is 22. Divide each side by 11. And you get y equals 2. How do I find x? I go back to my original problems and I plug y in for whichever one I want. Once again, I use that one because I'm inclined to use the positive ones. You know, I'm such a positive guy. So 2x plus 7 times, what does y equal? Y equals 2 equals 4. And now I've got my one equation with one variable, okay? Which is what I got when I use the elimination method too. I get 2x plus 14 equals 4. Subtract 14 from both sides. 2x is negative 10. Divide each side by 2. And you get x is negative 5. So the solution to the problem is negative 5, 2.